In this video, we will discuss about flip equivalent binary trees. For a binary tree T, we can define a flip operation as follows. Choose any node and swap the left and right child subtrees. A binary tree X is flip equivalent to a binary tree Y if and only if we can make X equal to Y after some number of flip operations. Given the roots of two binary trees, root 1 and root 2, return true if the two trees are flip equivalent or false otherwise. So what they're saying is that in the input, we are given the root of these two binary trees, right? Root 1 and root 2. Now we need to identify whether these two binary trees are flip equivalent or not if we can perform some number of swap operations. So in a swap operation, what they are saying is that you can choose any node. You can choose any node from this tree and you can swap its left subtree with the right subtree, right? So if let's suppose you have chosen this node 1, so you can swap its entire left subtree with the right subtree, right? So after 1 will the 3 node and its subtree will come here and 2 will go here like this, right? So this is one of the swap operations. So they are saying that after doing some of the swaps, can these two binary trees become flip equivalent or not? Flip equivalent meaning this binary tree, if after applying some swap operations, becomes completely equal to this binary tree, meaning it has the same structure, same number of nodes, and every node's value is also same, like exactly similar to this binary tree. So if we can make the first binary tree exactly equal to the second binary tree, after doing some number of swap operations, then that means these two binary trees are flip equivalent, and in that case we need to return true, otherwise we need to return false. Now in this case, if you see, if you start comparing, so this is the root node and this is the root node, both are having same values 1 and 1. So till here it is okay. Now you see for this 2, here is 3, right? Then that means now these are not equal, we will have to perform the swap operation, right? And swap operation we can perform for the left and right child subtrees, right? So if you want this 3 to come here and this 2 to go here, what you will have to do, you will choose this node. You will choose node having value 1 and then you will swap its left subtree and the right subtree, right? Then what will happen is what you will get. So this first node will remain as is. Now this right subtree will become the left subtree of 1. As is, it will be copied here. So it will be like this. And this entire left subtree will become the right subtree now. So it will be 2, 4, 5, 7, 8, right? Now you will see that this 3 and 2 now are matching with this, right? Now, if you will see this 6 and this 6, here 6 is the left child of 3, but here 6 is the right child, right? So then that means we can choose node 3 and we can swap its left and right subtree. So right subtree, it is null, right? So then if you will swap this and null, then the left subtree will be null and the right subtree will contain 6, right? So the next swap that we can do is for node 3. So then 6 will come here, right? Now this part is sorted. These are matching. Now if you see for the rest, here we have 2, here also we have 2. Then its left child is 4, here also left child is 4. Then 2's right child is 5, here also it is 5. Then for 5, its left child is 8, but here it is 7, right? And its right child is 7 and here the right child is 8. Then that means here also we will have to perform a swap, right? So if you choose node 5 and you swap 8 and 7, then what will happen? That 8 will come here and 7 will go here. Now are these equivalent? Yes. So now you can see that the entire tree has become equivalent to this binary tree. So in this case, we can say that yes, these two binary trees are flip equivalent, right? So now how are we going to approach this problem? So if you see here, for every node, we are having two possibilities, right? We are having two choices. One is that we do the swap of its left and right subtree, and the other is that we do not swap its left and right subtree, right? So what we'll do is we will explore both the possibilities for every node in our tree, right? Meaning for this 2, we'll check that what will happen if I will swap their left and right subtrees and what will happen if I don't, right? If in either of the two cases I am able to get the flip equivalent, then that means my overall answer will be flip equivalent, right? So we are not concerned that whether after swapping or after not swapping, these two binary trees are becoming flip equivalent. It's just that our target is that somehow can we make this binary tree flip equivalent to this binary tree, right? So that we can achieve either after doing some number of swap operations or after not doing any operations, right? If initially itself your two trees are flip equivalent, then you won't do any swap operation, right? And then in this case, we performed three swap operations. One was for node 1, another one was for node 3, and another one was node 5. Now let's suppose this 5 already had 8 and 7 here, right? Then in that case, you would have to perform only two swaps, right? So what am I saying is that for every node, we can either swap its left and right subtree, or we will keep as it is. And out of these two, if any one of them is telling me that okay, it is equivalent to the second binary tree, then I can say that yes, this particular part of my tree is flip equivalent to the second tree, right? So what we can do is, since we need to check for every node, we will do recursion here, right? For recursion, we'll create a recursive function. So let's name it flip, right? So it will give us a boolean whether the two trees are flip equivalent or not. So it will receive two pointers, one pointing to the current node of tree 1 and another pointing to the current node of tree 2. Right. Now inside this, the base conditions will come to that. First, let's understand what are we going to do. Right. So as I said that either I can swap the left and right subtrees of this and check with root 2, or I shouldn't, right? So one is that we are not swapping, right? One is that we are not swapping. So when you are not swapping, at that time, what you will check? You will have to check that the left subtree of the first binary tree should be equivalent to the left subtree of second binary tree, and the right subtree of the first binary tree should be equivalent to the right subtree of the second binary tree, right? This is the case when we are not swapping. So when you are not swapping, at that time what you will do? You will do flip, and in this you will pass root 1's left and root 2's left, right? Because we are comparing the left subtree of the first binary tree with the left subtree of the second binary tree, because we are not swapping, right? And another thing that we need to check is that the, we'll call flip, root 1's right should be flip equivalent to root 2's right. So this is the case when we are not swapping. Now, other cases that we are swapping the left and right subtrees. So in that case, what we'll check is, in that case, we'll check that is the left subtree of my first binary tree is flip equivalent to the right subtree of the second binary tree. And we'll check that if the right subtree of the first binary tree is flip equivalent to the left subtree of the second binary tree. Now, out of these two, if anyone is giving me that, okay, these are flip equivalent, then I can say that my two binary trees are flip equivalent, right? So here what will return? Will return the OR of no swap and swap, right? So this is our recursive function. So now let's come to the base conditions of it. So if you see, we are given two binary trees, right? Now let's suppose both of them are empty. The first binary tree is also not having any nodes and the second binary tree is also not having any nodes. In that case, we can consider them as null. So are these flip equivalent? Yes, right? Because both of them are not having any nodes. So the first base condition is that if your root 1 is null, right? And your root 2 is also null. In that case, your answer will be true, right? Now, let's come to the second scenario. So the next scenario is that one of the subtrees is having some number of nodes and the another tree is not having any nodes. It is null. Now, in that case, will you ever be able to do some swap operations and make them flip equivalent? No, right? Because here we are not having any nodes. Here we are having some nodes. We can never make them flip equivalent. So that's why the other condition is that if either of them if either of them is null, in that case our answer will be false. Both are null, that we have already checked. Here we are checking if either of them is null, right? Now another base condition, what I'm saying. So if you see in a swap operation, we choose a node and we swap its left and right subtree, right? The node that we have chosen, that remains as is. Now, if the node's value itself for these two binary trees is different, will you ever be able to make them flip equivalent? No, right? So another base condition is that if the value of root 1 is not equals to the value of root 2, then in that case also it will be false, right? So these are all our base conditions and the main operations that we are going to perform, and this will be our algorithm. So now let's code it out. So here we will keep flip equivalent as a recursive function because here also we are returning a boolean and we are getting the pointers to nodes of both the trees, right? So here we will first put our base conditions. So we'll check that if root 1 is a null pointer and root 2 is also a null pointer, in that case we will return true because both are empty. Then if my root 1 is null pointer or root 2 is null pointer, meaning either of them is empty and the other is not, then in that case our answer will be false. Other one is that the root 1's value is not equals to root 2's value, right? In that case also you will return false because this condition will hold when your nodes values are not equal. So in that case you will have to perform a swap operation, right? So that's why we are returning false here. Then we will check for no swap and swap. So we'll do bool no swap. So in that case we will call our recursive function which is flip equivalent. In this we will pass the left subtree of the first binary tree and the left subtree of the second binary tree, right? So these both should be flip equivalent, and again we'll call this, and then we will pass the right subtree of both the trees, right? Root 1's right and root 2's right. So this will give me whether are these flip equivalent or not if I do not swap. Then if I swap, then in that case what we'll do, we'll again call this function, we'll pass left subtree here and right subtree here, right? Because we are swapping it. And then here we'll check that root 1's right and root 2's left, right? And if either of them is giving me that they are flip equivalent, then I'll return they are flip equivalent. So return no swap or swap. So let's run this now. So our test cases are accepted. Now let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.